Okay, so here we go. We're talking about all kinds of log stuff. This is level 2, easy stuff, not quadratic. You just got to know how to like combine stuff. Like these two can go together, and do you get that that would make log base 4? And how do I put something that's been added, put it together? What do I make? Multiply. So it's the 4x times the 2, which would make what? 8x is equal to 2. Now, whenever you're looking at a log question, your best way to solve them is by rewriting them as the other way. This one's a log, so let's make it into a what? Exponential. 4 to the second is equal to 8x. And look at that, the x is almost alone. As soon as the x is alone, I'm done. That's what the point of solving is. So now this is 16 equals 8x, and then I just divide by 8, and I get 2. You get that? You see what that's in R2? Pretty easy. Okay. Next one. This one is an exponential. You could rewrite it as a log, but there's an even smarter way. Do you see that 125 and that 5? Do you get how they could sort of be written with the same base? Rewrite them with the same base first. If you try rewriting it as an exponential, it's not going to go so well. Or, sorry, as a log. You could take the log of both sides again. It wouldn't go so well. You'd need to get the bases the same to fix this one. So it's this number right here that's our problem child. If we could get that rewritten as a 5. Well, that's easy. What is 125? 5 cubed. So I put a 5 cubed right here instead of the 125. And I still put the to the power of x minus 1, or plus 1, sorry. So I just rewrote the whole problem and replaced the 125 with a 5 cubed. Now, this and this are the same base. And so this has to equal this. Oh, I just missed it. That. Get how the green stuff has to equal each other? So then x over 2 equals 3 times x plus 1. Now, so often kids forget and drop the plus 1 and they say this is just 3x plus 1. Can't do that. What is it? 3x plus 3. All right. So first thing I would do probably is to multiply everything by 2. That gets rid of my fraction problem. There's only one term here. It's a big multiply term, so I only multiply one thing by 2. X equals 6, x plus 1, and now I'm getting closer. I could, let's see, I could multiply it out. X equals 6x plus 6, and then this is just algebra from here. And we really don't have time to do lots of just algebra, because if you don't have the algebra skills at all by now, you're in deep trouble. I subtract 6 from both sides. I'm not saying you wouldn't make a mistake occasionally, but if you generally don't know how to solve equations, you're in trouble. There we go. Any questions on that? So let's start with what happened. We had to make the bases the same. Don't forget how to do that. Okay, next topic. Write this one down. I've chosen these problems very carefully and logically to get you ready. First thought. You might be thinking, okay, you always said that if you could rewrite it to the other form, that would be smart. That is generally true, but I can't rewrite this one yet. I have to get it into exponential form, and it's not an exponential form yet. I got to get it down so this right here, this part right here is all alone. Then I could rewrite it as log base e blah blah blah. So I got to get rid of this and this. Do that, and see if you do the steps in the right order. Now don't go grab a calculator, because this is one of those teachable moments. I know you don't know what 32 divided by 3 is in your head. That's okay. You're going to have problems like this, where on the test, you don't get to use a calculator. That's officially been decided. So, how the heck are you supposed to do this without a calculator? You aren't. You leave it alone. You can leave it the way it is. It'll be kind of messy. But all I have to do is get the x alone. So I do not have to know what 32 divided by 3 is. Some decimal. I don't have to know that. I leave it as 32 thirds. Next, rewrite it as a log. Log base e, if you wanted to go to ln right off the bat, that'd be fine, of 32 over 3. You go from here over to here and then back to here. X over 3. Now again, it's starting to get messy, but that's okay. What's the goal? Get x alone. Is x almost alone? Yeah. What do I got to do now to get it all alone? Multiply by 3. If I multiply by 3 on both sides, times 3 here, times 3 here, then it's x is alone. And there it is. 3 log base e of 32 thirds. And it's okay to leave an answer like that, as long as it isn't something you could simplify. If this had been, for instance, 3 log base 2 of 2 to the third, and you left it that way, I'd have to mark it wrong. Why would that one have had an answer? Because this part right here equals what? 3. But if it doesn't come out nice like that, then you can just leave it. So you better be sure that you're not missing something. Like if you were about to write this as your answer, you should go, oh, wait a minute, that simplifies to 3. So it's really 3 times 3 equals x. So my answer is really 9. So look to see if it'll simplify, but if it won't, it's okay. In the back.
Why did you add first?
All right. I was trying to get this part right here alone. So there's 2 steps. So you got to get rid of that, and you got to get rid of this 3. You always, whenever you had simple ones like this, 3x plus 12 equals 15, you remember how you get rid of that first? And then you get rid of that? That's why. So I started by adding 11 to both sides. And then I divide by 3 on both sides. Okay. Yes, question? Yep. Yep. This 3 and this 3, you're asking if those could cancel. No, they can't, because this one's in the middle. Technically, it should probably have a little parenthesis around it right here, and that might have made you notice. That's not like a normal fraction, because it's the argument of this log. So, nope, these 3's would not just cancel each other. I don't know a better way to say that. If this whole thing had been divided by 3, that'd be different. If this whole thing was being divided by 3, then I could have canceled it. But only the argument part is being divided by 3. Yes?
So if you take 2 over 3, wouldn't it be a simple 5 or just equal?
I would have left it this way right here. I would have left this not simplified. Oh, I see what you're saying. Could you have moved this 3 up to here? Sure. But that's not something you would have had to do. It would have been okay to leave it the way it is. It didn't say condense it. It said solve it. Is x alone is what I'm going to ask myself when I'm looking at these. And x is alone. And then is there any simplification that they could have done? Like was it log base e of e or something that could have simplified down to a number? And if it can't, you're going to have messy answers like this, and that's okay. All right? I do get your point that you could have put the 3 up here as an exponent on this, and that would have also been okay, but not necessarily better. Okay? All right. Moving on. Here's another one. This is a little bit tougher, but it's still not quadratic, and the quadratics are the really scary ones. So we'll save those for the end. On this one, the thing I was afraid a lot of kids won't do, so I'm just going to tell you to keep you from wasting a lot of time. You got to put this up on this kind of a problem. Otherwise, you won't have 2 logs that are exactly the same, and you won't be able to cancel them. That's pretty easy once I tell you that. This part, a little harder to put together. And again, you're not going to have a calculator, so you're not expecting you to like graph this to get the answer. So you're going to go, okay, this is a plus, so this can be put together as a times. Log of x plus 5 times x is equal to, why can't I just leave this log like this? Because then I couldn't cancel my logs off. If I have two plain old logs, this 2 is out of here, and if I move him up here instead, if I have two plain logs like this, common log here and a common log there, or if they'd been the same base, like log 6 and a log 6, then they can cancel. It's not actually canceling, I should tell you that. But bottom line is that this part has to equal this part. And so then I got my new equation. It doesn't even have logs anymore, and it's way easier. X plus 5 times x, usually put the x in front of that, is equal to 9, because 3 squared is 9. See what I just did there? This part has to equal this part, because the logs just canceled off. And now doesn't that look like a quadratic? And you know how to solve quadratics, right? Get it all onto one side, then you can factor it, or you can use quadratic formula. You won't be able to graph it because there's no graphing calculators. All right, so let's not solve this the rest of the way. We'll talk more about quadratics in a bit. This actually is quadratic, but it's nice kind of quadratic because at the end you don't have to substitute logs back into it. I just solved this and I'd have my answers. Why isn't it just -5 and 0? Because it's not equaling 0 right now. It's equaling 9. All right, so you'd go x squared plus 5x equals 9. Then you get the 9 to the other side. X squared plus 5x minus 9 equals 0. Then you'd factor it. And if it didn't factor, you use quadratic formula. Okay? Get it equal to 0 first. Yes? Generally, we like the ones that factor. Yes. Do you know the quadratic formula, though? Negative b. Yep, you got it. So then a, b, and c, if we go back to this other one here, a would be this, 1, b would be 5, c would be -9, stick them all in. Again, if you have an answer that's got like square root of 17 in it, you just leave it that way because we know you can't do that in your head. Okay? All right, moving on. This one's not a quadratic. The last one I said it wasn't, but this one actually isn't. It's like one of those other ones where you're going to have your answer left. Oh, we got a visitor. Okay, we had our interruption passed, and so here you'd subtract 3 from both sides, right? 2x to the -2 equals 94, and then I divide by 2. X to the -2 equals half of 90 is 45, half of 4 is 2, 45 plus 2 is 47. That much I could do in my head. Do you really think that I'd expect you to know the square root of 47? I wouldn't expect that. So, why am I getting square root at the end here? Because first, to get rid of this, to get this to be an x to the 1, I need to multiply this by -1/2. So I'm putting it to the -1/2 power. I'm going to put this side to the -1/2 power. You get how that cancels that and it becomes x to the 1? Is x alone? Yes. Do I expect you to know how to do 47 to the -1/2 power in your head? No, I don't. So that'd be a good enough answer right there. You get how you can leave things that are kind of ugly since you don't have a graphic calculator? All right. It's one of the themes for the day. All right. Moving on. Here is a quadratic. You should be able to just solve this. It'll factor. So factor it, solve it. Got to be able to do that, otherwise you won't have a chance at solving the log ones. So try this one. In case you're struggling, I'll get you started. 2x and x. And then to get a 7, it's got to be a 7 and a 1 in the other spots. And then you just got to mess around with the negatives and positives to make it work. All right, let me try this one. 7 and a 1. And then I got to have one of them be negative. I'm going to try making this one negative. And I check, and I go outside, -2. Inside, +5. That makes it, or 7. That makes a total of +5x. Do you know what to do when you get the exact opposite of what you wanted? Switch the signs. You leave the numbers where they are and switch the signs. If this was positive, I make it negative. And if this was negative, I make it positive. And now it will work out perfect. So whenever you get the exact opposite of what you wanted for the middle term, switch signs around. Okay, so now I have my answer, x equals -1. And over here, what if I can't do that in my head? I go 2x minus 7 equals 0. 2x equals +7. X equals 7 over 2. Yay! They won't be quite that easy on the test, though. Because, not that factoring part, that's about right for the factoring part. But the problem will start as that. Which looks all messy, but as soon as you yoink out the log x and replace it with a x, then it just turns into this problem. Exact same problem. See, when I take this and make this into just an x, notice it's squared, then it's 2x squared minus, take this out and make it just an x. 5x minus 7 equals 0. I took my log x's out and replaced them with x's. Now I have to pay for that someday. At the end of the problem, once I've solved it, and you remember what the answers were? X equaled what was it? -1, and x equaled 7 over 2, okay? Then at the end of the problem, when I've got these two answers, I got to pay the piper. And I made this swap back then to make it easier for myself, and now I have to fix that and replace x back with what it really was, log x. And then I have to solve those, which really isn't that bad. This is a base 10, so it's 10 to the 1 is equal to x. And then that one's, sorry, -1. And then that one is 0.1 or 1/10. This side, I'm not going to know what 10 to the 7/2 power is, am I? So I can leave it that way. All right. That's one where we started with a quadratic that was a log quadratic. And we replaced the logs with x's. And then we factored this down. We already did that on the last slide. 2x and x and -7 and +1. And then I took my answers and had to do one last substitution at the end. That's kind of the main process. Let's see if you can handle that yourself for this kind. This one, it looks like it's not a quadratic. But as soon as you multiply by x all the way through to get rid of this x in the denominator, then it will be a quadratic. Go ahead and do that. Tell me what you get. Yes? Mm-hmm. Yes, if you start with a log base 5 and you swap out an x for that, then at the end, when you re-swap it back in, just put in a log base 5 at the end. Nope. They'll have to always be the same, but we won't give you one with two different bases in the same problem. You'd have to have a calculator to do that. So it'll always be the same base log through the whole problem, like a log 7 and another log 7. All right, so do you get that if I multiply by x here and by here and here and here, I get, these x's would cancel and I get 2. These make a 3x squared, and that's why it's a quadratic. And this 5 times the x makes 5x. 0 times x is 0. There we go. It's just a little jumbled up, but it's a quadratic. Yes, sir? Whenever you have an equation, let's say it was 2x plus 5 is equal to 12. Maybe you didn't know this, but if I wanted to divide by 2 on this problem, I'd have to divide everything by 2. Or if I wanted to multiply by 6, I'd have to multiply this by 6, and this by 6, and this by 6. You have to do it to every term. I'll give you proof. Let's say I had 1 plus 1 equals 2. Do you agree with that? If I multiply through by 3, and I multiply by 3 here, by 3 here, by 3 here, it better work. 3 times 1 is 3, plus 3 times 1 is 3, equals 2 times 3 is 6. See, it worked. you have to multiply everything by 2. All right, so moving back to this one, we multiplied everything by x, that by x, and that by x, and that by x, and that by x, everything. Every separate term. And I got this. Does that look like a quadratic to you? Good. Factor it. Three x and x. At least it starts off easy. And 2's not bad, because there's only one way to make a 2, right? 2 times 1. So now it's just a matter of, is it this way? I don't know. I'll check. Outside and inside better make 5. And they do. So that was the right way. So then I have x equals -1, and 3x plus 2 equals 0. Solve that. 3x equals -2, x equals -2/3. Raise your hand if you followed me through that. You get that part. Okay, good. So then what if it's like this on the test? Does that look like the same thing? Yeah, it pretty much is. Except you're going to have to swap the x for the log. So you're going to end up saying that this is an x and that's an x. So now it's 2 over x plus 3x plus 5 equals 0. And that's the exact problem we just did. We have the answer for it right there. -1 and -2/3. So if the answers I know come out to -1 and -2/3, then what's different about this then? I got to resubstitute it at the end. I just made the swap to make my life easier, and I put an x in instead of these two. So now I got to go back and make my life a little more complicated at the end and make this a log x, make this a log x, and then I solve them by saying, oh, base 10, 10 to the -1, and this one's again base 10, 10 to the -2/3. About my answers. All right. You made it through. Now there's still one more hard kind of problem I'm going to talk to you about on Tuesday, just right before the tests, because I think your brain's full enough right now, and you'll have one last thing to, it's not really to learn, it's just one more kind of way to do a quadratic. So today's homework is a worksheet. The answers are all posted. So please use the rest of the time to ask questions. There's like 15 minutes left. You can ask questions while I'm here. If you're stuck on old homework, you can ask those questions. If you get stuck on one of these problems I'm about to give you, ask me those.